Assalamualaikum. So we will continue, okay, for the part 2 of differentiation of logarithmic and exponential function. Okay, so in the previous video, we already learned how to differentiate, okay, a ln or log function. So in this video, we will learn how to differentiate exponential function. Okay, so for exponential function, okay, if we have a function of ex, okay, so when we want to differentiate this function with respect to x, okay, we will get ex, okay. And another thing is the same thing. If we have a function of eu and we want to differentiate this function in term of u, we will get back eu, okay. So however, if we have a function of exponential ux, okay, where the power is another function in terms of x. So we want to differentiate this function with respect to x. Okay, so we will get exponential ux times du dx. So that means we have to differentiate ux, okay, with respect to x, and we time back with the original function. Okay, so let's see the first example of exponential function. Okay, so I'll give a very simple one. Okay, if we have a function of y equal to exponent 2x squared. Okay, exponent 2x squared. So now we will assume this one as u. Okay, so we have u equal to 2x squared. All right, so du dx, we will get 4x. Okay, so since 2x squared is u, now our y become eu. So dy du, we will get exponent u. Okay, so how can we solve this one? We can solve this one by using chain rule. So to differentiate the function, okay, dy dx is equal to dy over du time with du dx. Okay, so we just substitute our dy over du is exponent u. Okay, so du dx is 4x. Okay, now we just substitute back our u with 2x squared. Okay, 2x squared. So when we substitute, we will get the answer will be exponent 2x squared times 4x. Okay, so this is the answer. Right, so let's see the second example. So for example, we have y equal to 2x. Okay, again, a very simple one. So we need to assume the power, okay, the 2x is equal to u. So now du dx will become 2. Okay, so our y now become eu. So dy du, we will get eu. Okay, so again by using chain rule, okay, dy dx is equal to dy over du time with du dx. So again we just substitute very simple eu time with 2. Okay, so we just substitute back our u with 2x. So now finally the answer will be 2e 2x. Okay, very simple. Okay, let's see the third example. Okay, so if we are given a function of y equal to exponent sine 2x squared. Okay, exponent 2x squared. So this question we have just a bit different. Okay, because this time, okay, you see we have sine 2x squared, so we will assume 2x squared as u. Okay, so now we will have u equal to 2x squared. Okay, meanwhile we will assume the whole this one sine 2x square, or we can say simply wrote it as sine u. Okay, so now we just assume v equal to sine u. Okay, and so due to this, therefore our y become exponent, okay, exponent v. Okay, exponent v. Okay, so in this question, we can use chain rule. So what will be the formula is dy dx equal to dy over dv times dv over du times du over dx. Okay, so therefore we need to find dy over dv, dv over du, and du over dx. Okay, so from here we know that du over dx is equal to, okay, 4x. Okay, so dv over du, okay, dv over du, we will get cos u. And finally, dy over dv, we will get back EV. Okay, so we already have everything that we need. So we just substitute into the formula. Okay, we just substitute into the formula. Okay, so now we know that dy over dx is equal to dy over dv is EV. Okay, and then dv over du is cos u. And then our du dx is 4x. Okay, so therefore we just replace back. Okay, we just replace. So our v is sine, okay, sine 2x squared. Okay, sine 2x squared. So cos u, what is our u? Our u is 2x squared, and finally 4x. So finally we can rearrange this one. So we get 4x exponent, okay, sine 2x squared times with cos 2x squared. So this is the answer. Okay, so let's move to the example number 4. Okay, example number 4. Okay, if we are given a function of y equal to exponent 2x minus 1 over exponent 2x power of 2. Okay, so how can we solve this one? Okay, we can solve this one by using chain rule. Okay, we can solve this one by using chain rule. So we assume the one inside the bracket as u. Okay, so now we have u equal to exponent 2x minus 1 over exponent 2x. Okay, so therefore y is equal to u square. Okay, so now our u, we can rearrange or rewrite as exponent 2x minus exponent negative 2x. Okay, so we need to find du dx. Okay, so du dx, so we will get exponent 2x, okay, time with 2, okay, because we differentiate 2x, we will get 2, alright, so minus exponent negative 2x with time with negative 2. Right. So finally, here we will get 2 exponent 2x plus, okay, plus uh, 2, okay, exponent uh, negative 2x. Okay, this is our du dx. So our du dx is 2 exponent 2x plus 2 exponent negative 2x. So meanwhile, our dy du, okay, dy over du is equal to 2u. Right. So now we just insert into the formula. Okay. So we know that chain rule dy over dx is equal to dy over du time with du over dx. So our dy over du is 2u. Okay. And then our du dx just now we already calculated. We get 2 exponent 2x plus 2 exponent negative 2x. Okay. So we just replace back our u. U is equal to, okay, exponent 2x minus exponent negative 2x. Okay, we just write back 2x plus 2 exponent negative 2x. Okay, so from here we can factorize the 2, isn't it? So we can factorize the 2 from here, and then I just multiply with the 2 here in front, so I get 4. Okay, so 4 exponent 2x minus exponent negative 2x, okay, time with exponent 2x plus exponent negative 2x. Okay, when you just expand, okay, finally the answer will be 4, okay, exponent 4x minus exponent negative 4x. So this is the answer. Okay, so we will stop here and we will continue the next subtopic in another video. Thank you.